For my physics culminating, I chose a scene from SkyFall to analyze using physics concepts. To set the stage, I will briefly discuss the events leading up to my chosen scene. James Bond is chasing a villain named Patrice on a motorbike through the streets of Istanbul, Turkey. The reason is because Patrice is carrying a chip with the information of all undercover MI6 agents. Eventually, James Bond corners the villain on an overpass. The scene I chose begins with the antagonist jumping off a bridge onto a train that is in uniform motion. After landing on the train, he then starts to run, accelerating in the same direction as the train. James Bond, knowing he needs to catch the bad guy, accelerates his motorcycle towards a solid railing, purposely crashing into it, launching himself forward. He just barely lands on the train, almost rolls off, but catches himself with one hand. He then pulls himself onto the train against the force of gravity using both of his arms. The first thing I did was figure out James Bond's time of flight when he launches off the motorcycle and lands on the train. I did this by timing it with a stopwatch. His total time of flight was 2.9 seconds. The next thing I decided to do was find out the vertical distance he had traveled. To do this, I took a screenshot of a frame showing him in freefall with a full view of the bridge and train. Using this screenshot and a ruler, I found out that he fit in between the bridge and train roughly 2.5 times. Daniel Craig, the actor who plays James Bond in Skyfall, is 5'10". Using this information, I can find the vertical displacement by multiplying 1.78 meters, which is 5 foot 10 inches in meters, by 2.5. 1.78 times 2.5 equals 4.45. Therefore, the vertical distance he traveled was 4.45 meters. Using the time of flight and vertical distance I gathered, I was able to calculate the vertical velocity average. To calculate the vertical velocity average, I used the formula Vy equals delta dy divided by t. Since delta dy equals 4.5 meters and t equals 2.9 seconds, the vertical velocity average was 1.53 meters per second. I will now move on to calculating the work done when James Bond pulls himself onto the train. To do this, I use the formula work equals force times distance times cos theta. Because theta equals 0 degrees, since he performs a completely vertical muscle up, and cos 0 equals 1, I can take out cos theta from the equation. To calculate the work done, I first needed to figure out the force he used. In this case, the force required for a muscle up involves lifting the body against gravity. The force needed is equal to gravitational force pulling the body downward. The formula for gravitational force near the Earth's surface is Fg equals mass times acceleration due to gravity. The acceleration due to gravity on Earth is approximately 9.8 meters per second squared. To find James Bond's mass, I did a quick Google search on the actor Daniel Craig and found it to be 77 kilograms. The calculation for force would be F net equals Fg. Since Fg equals mass times 9.8, the calculation would be 77 times 9.8, which equals 755 newtons. After calculating the force, I then started to calculate the distance he pulls himself up. To do this, I needed to find out the length of his arms, but since there is no listing on Daniel Craig's wingspan, I searched up the average arm length of a 5'10" male, which is 83.82 centimeters. To calculate the distance, I needed to multiply the arm length by 2 because he goes that distance once by having his arms fully extended and does a pull-up. The second time he goes that distance is fully extending his right arm to put his entire body on the train. 83.82 times 2 is 167.6 centimeters. Turning that into meters is 1.67 meters. Using the force and distance I calculated, I was able to calculate work using the formula I mentioned before. Remember, I was able to take cos theta out of the equation because in my case it would equal 1. Having a force of 755 newtons and a distance of 1.67 meters, the work done will equal to 1,260 joules. That concludes my physics analysis of this scene. Thank you very much for watching.